All right, ladies and gentlemen, so here we are. This is the final unit of the school year. If you are hearing my voice, that means that you have made it down to the final 3 or 4 weeks of school. You're still in it. Hopefully, your grades and everything are doing well. This last unit is on quadratics, and I'm going to teach you some things that you've probably never seen before, but that's okay. This is something that you may not see so much in geometry, but you will definitely see in Algebra 2, so you really got to pay attention. So we're going to talk about quadratic functions, and I'm going to start you off with graphing quadratic functions, okay? So let's get us a definition. You've heard the term quadratic before in Unit 10 when we were talking about polynomials. Quadratic describes a degree, a number, a certain number, which is your degree. So if you remember that quadratic stands for second degree, the definition of a quadratic function is basically a second degree polynomial, right? Now, we're not going to start off with a trinomial. We're going to work our way to the trinomial. So I'm just going to leave it as polynomial, all right? But it's definitely going to be second degree. So that's your definition of a quadratic function. It's a second degree polynomial. Now, your next sentence on your notes, a quadratic function is always written, or should be always written, in the standard form ax squared plus bx plus c. Now, you've seen this before as well, because when I showed you how to factor in the last unit, it had to be in this form for you to set up your X box. Now, what I'm going to do today, or in this section, is we're going to break this form apart and only talk about different pieces of it and how we graph. So this goes in your blank where it says a quadratic function should be written as, right? So far, so good. Now, your next blank talks about the graph of a parabola, okay? And this is probably something totally brand new, and this is where we're going to stay for the next day or two. When we talk about the graph of a quadratic function, it has a special name, and that special name is a parabola. The graph of a quadratic function is called a parabola. A parabola, if you look at it, is U-shaped. And what I want to do next is just break down the way your parabola would look. But before we do that, you've got some space on your notes. Why don't you go ahead and draw on your notes right there a nice little XY coordinate plane. And let's just throw in a parabola. A parabola is U-shaped. So let's just take in your first quadrant a simple U like that, and you want to put your arrows up there to show that it's continuous, because it is. Now, the first part of a parabola you need to know is the axis. Can you see that? Axis of symmetry. Write that down. Your axis of symmetry, and I'll write this down, is a vertical line. I can't spell vertical. Vertical line straight down the middle of the parabola, okay? Axis of symmetry. It simply breaks your parabola in half so that you have the same thing on both sides. So I'm going to take another color here. My axis of symmetry, I'm going to eyeball it, but we'll have it for real when we start graphing. If you just kind of get the center, the middle of your parabola, this orange line is your axis of symmetry, okay? It cuts your parabola in half. Like if I was to fold it, you would see two equal halves. Then the second part of your parabola that you need to be aware of is called the vertex, all right? So we have our axis of symmetry and we have our vertex. The vertex will be the highest or lowest, depending on how your parabola is opening. It's the highest or lowest point on a parabola, okay? Highest or lowest point. Gonna be easy to find. It's the point where the curve changes direction. That's the cool part about it. And if we talk about a min or maximum value of the parabola, so write this down, min or max value, that's going to be the y coordinate of the parabola, of the vertex, of the vertex. Because remember, your vertex is a point. It's going to have an x coordinate and a y coordinate. So if I take my orange marker again, your vertex is always going to lie on your axis of symmetry. So right at the bottom of my parabola, that's where I would say that's where my vertex is. This is the point where it's going down, and then it turns direction and starts going up. Okay? So write this down, and in the next video, we're going to